Hello and welcome to part 2 of our Racing Downhill Jam game. We did the character controller, we did camera follow in about 3 minutes using Cinemachine, and we brought in some art assets and got to learn just a teeny little bit of playing with the tile map. So now we're going to work on the pickups and the race manager, which we're going to need to keep track of the timer for the game, so when we have a pickup, it can do something. But we're going to do the pickups first because that's the real heart of this programming assignment, this following project, which is to have sort of a nice system for that. So we're going to make some new scripts so the car can overlap something, and when it overlaps something, it can know. And that we'll use for the finish line, we'll use for the checkpoints, and we'll use for any other weird instantly activated power-ups. Maybe there's a, as opposed to like a power-up you get in Mario Kart where you collect it and then you have it, that might be something else. This is just like you hit a checkpoint, you hit the finish line, you hit a thing that activates, like opens a door for a shortcut, or some kind of key, like switch that you drive over, maybe a boost pad that gives you a speed boost, things like that. So let's do it. So to do that, we are going to use an onTriggerEnter2D event to overlap a trigger and use that for the project. We could add that to our car controller, but I know I'm not going to. I want to sort of separate this logic out to its own separate system, and a little collection of code that talks to each other and doesn't really have anything to do with the car controller. So we're going to make a new C# script, and we're going to call it car interactable handler, interactable handler. And the car interactable handler is going to handle interactions for the car. It could be a car interaction handler, but this is interacting specifically with things that I'm going to call interactables and not with anything. So it's the interactable interaction handler. And this is going to use that onTriggerEnter2D Unity event or event function. onTriggerEnter2D. Great. I'm going to make a new folder in my scripts folder, and I'm going to sort of organize my code a little bit. So let's make a new folder, and let's call it car controller. And our car input and our car controller can go there. Often our input would go into an input folder, but I'm just going to throw those two scripts together because they deal with each other. I'm going to make another new folder, and I'm going to call this one interactables. And we'll put our car interaction in there. So we'll let JetBrains Rider sort of refresh for a sec because we just move things around. You'll notice that my stuff's like turned red here. That's because I've created a Git repository so that I can have the project up on GitHub and you can see it. And that's just some feedback from GitHub. So you can totally ignore that. I just want you to not think that that's because there's an error. So we're going to make a component that's going to be our interactable. Let's add a new Unity script. I'll do this from JetBrains Rider, and let's call it interactable. So our interactable is now a component that we can add to anything in the scene. So let's go ahead and make a placeholder checkpoint for ourselves. I'm going to use a square. Give it a box collider, 2D, and make that a is trigger. Otherwise, my player is going to hit this and go bonk. And I'll make that thinner. And we'll call this checkpoint. And our car, we can start down here. And our checkpoint, we can put at the top of this incredibly difficult track that we have so far. And the checkpoint is going to have a interactable, but it's not going to have an interactable. It's going to have a checkpoint script, and that checkpoint script is going to inherit from interactable. So the interactable script is going to have a interact or on-car overlap, perhaps. But I'm just going to say interact because my students have done the interaction assignment, and they're going to go, oh, this is the answer to the homework assignment we had last week. Oh my gosh. And then here we're going to get a interactable. And it made a namespace, and I'm going to get rid of the namespace even though I like them and I want to use them. Interactable equals, and we can call the get component function right on our box collider. And that's me trusting that they're going to be on the same game object. And my interactable is not going to be like on the parent object that has a bunch of collider children. And that's going to get the interactable component of the interactable. So if the checkpoint had that script on it, if it had the interactable script on it, then when we overlap the checkpoint, that would not be null. So that's not equals to empty. If we overlap something else, like maybe we're using triggers to do our ground or grass friction settings differently, then it would not have an interactable, and this would be null, and we would skip it and do nothing in this function. But here we will call the interact function, which is that function that we just wrote there. It does nothing. I'm going to do debug.log interact. And before testing this next setup where I have to make sure everything works with my polymorphism and my object-oriented hierarchy, let me make sure everything works in my physics settings. So I go to my car and I can give it a interactable handler. Kind of just, there's no settings for this script. We just kind of add it. Love that. And then that is a trigger, and the car is a rigid body, and the checkpoint doesn't, and the box collider and the interactable are on the same game object. So, and we're all on the same layer. We haven't played with layer settings yet, so we should be good. This should work. We should see a message in our console that says, boom, interact. Interact again. Interact again. Interact again. Okay, so that's something to keep in mind. We don't want to be able to drive back and forth over a checkpoint and just keep getting it. We're going to want to keep track of how many times we've hit it. But we'll deal with that in a second. Let's make our checkpoint. Let's add a new Unity script and call it checkpoint. Again, I'm going to keep it in that folder. Ignore git things. And instead of inheriting from, give that namespace, instead of inheriting from mono behavior, we're going to inherit from interactable. And interactable is going to inherit from mono behavior. So this checkpoint is still a mono behavior. We can still add it to the components. But what we need now is to override this interact function. So I need to do that, but I'm going to get an error if I do that. I want to override the one in the parent class. I won't get an error, it just won't do anything. But I want to override it, and it says there's no suitable method to override, and that's because in my code I have not explicitly given permission to allow for overrides, and I do that with the virtual keyword. So a parent class has a virtual thing that a child class can override. We already have some other things we can override. We can override like toString and get hash code and equals, and those are all part of sort of the object system that's like well above mono behavior. Mono behavior doesn't have any virtual functions in it, but it inherits from other classes that do. So neat. Cool. So now we have our checkpoint is overriding the base class, and it is providing its own new functionality, which is to debug.log a different message than what is in the base class. So now if we go over the checkpoint, it should say checkpoint and not interact. Even though the player interaction handler doesn't know anything about checkpoints. It says interact. Because I did not put a checkpoint script on my checkpoint, I only have an interactable on my checkpoint. So let's remove that and add a checkpoint. And we hit our checkpoint. So our car interaction handler is completely ignorant of the existence of checkpoints. I have added the new feature to my game of a checkpoint without editing my car at all, which is cool. And we'll be able to add a new finish line interactable to our game without having to add any logic to the car's overlapping of interactables. It'll work, and we can just add a finish line by writing some code that's the finish line, and then the finish line is a finish line, and we're done. And if we delete it, then we lose it, and we're fine, and nothing. We don't have to go and delete a bunch of references anywhere else, and it's such a nice way to work. Okay, so cool. For what it's worth, we could call the base.interact class, which would run this function, and then when it's done running it right here, it would run this function. So sometimes we don't want to replace logic that is in the parent class, but we want to extend it. And that's true if we're using mono behaviors and we have something like awake or start or update. You generally want to make the parent class have those be virtual, and then child classes, you want to call the base classes like awake function, and then add your own features you had to add after. That's sort of a common hiccup and kind of a pain with these features. Let's add another feature to our interactable, which is going to keep track of how many times the player has hit it. And it's going to even give us another function called like first interaction. So we're going to make a integer called times interacted with, and we'll set that to be 0 when we start. And every time we interact, we will increase it. And then in our child, since we can call base.interaction, that will get increased. And then we could do something like if times interacted with, which is private, so it can't be accessed. I'm gonna make that protected. Times interacted with is 0, which we'd have to do above this base.interaction. Only then would we be like so we could do the code this way. We won't, and you've been copying me, and you're like, wait, what? But we won't because it's not as clean as it could. It could be even cleaner. The reason it's not that clean is because the child has to know a lot about how the parent's logic works, and there's some things to set up in the child. There we go. So we're getting first checkpoint and then another checkpoint every time. And when we set up the child, it needs to know that it should call base after it checks this variable. So it needs to know that in the base, this variable is being modified so that it can do it at the right time. And it also needs to remember to call that, and it needs to know that this variable exists at all. And all that's perfectly valid. We're writing the code. It can just work. But I would like something even better. I would like to move this checking the interaction stuff to the parent class. So I would like my code to just be that. Like, this is to me how I want to write the child's code. So let me structure my project in a way that lets me, I'm going to have very few interactables that are going to be on their own, like exist at all. All the logic will be in the children. So let me make that nice and easy to work with for myself. So we're going to do a public virtual void first interaction. And we're going to say if times interacted with is 0, first interaction. And then otherwise, or always, we will increase that number. And this will do nothing. So we could make it abstract, but we won't. So here we'll just override the first interaction. And that's it. So I just move that logic into the base class. Turns out we want the same thing for the finish line that we know we're going to make. You don't want to be able to go over the finish line multiple times and stop the timer again and win again. That'll mess up things. And now my checkpoint code is as clean as can be. love that. I would still need to know to call the base.interact function. So maybe we do, maybe we write more of these like other empty virtual functions, like another interaction, and we put that here and we just override that. I'm going to keep the code as simple as possible and not add any complexity until we actually need it. So there we go. You can see this is grayed out because nothing is inheriting from interact. It is only on that only inheriting first interaction because we only have one child class and it only has one function. So, but it's fine. Now let's make the finish line. So I'm going to add a new Unity script. I'm going to call it finish line and get rid of the namespace, even though it hurts me to do so, and make this overlap interactable and override the first interaction function. And now we can debug.log, you win. And just a placeholder. Let's add a finish line. Looks like we have some finish line tile art here, but I'm just gonna duplicate this game object and move it up and maybe change its color to green. And we'll change its checkpoint to finish line and its name to finish line. And let's test it. So I should hit a checkpoint and then the finish line. I mean, I could go around the checkpoint, but I should see in the console two different debug.log statements, two different functions again, and we didn't have to touch the car code at all. How nice is that to work with? No more if, no if statement if I hit a finish line and also a checkpoint, but if I hit this, but if I hit that, it's so nice, so clean. Okay. Cool, let's make it a game now. Let's make a race manager. I'm gonna say race manager and not game manager, because how I imagine this kind of game working is that there are like 3 races in a set and they each get progressively harder and then you win, and that game manager is gonna control that bigger loop and then we're just gonna control one race. And that's all the code we're gonna get to in these videos. We're just gonna do one race, a countdown timer, and it's gonna hit 0 and you're gonna lose, or you're gonna win and you have checkpoints that will add to the timer and a finish line that will stop it to the win state. So let's add a new little folder for our managers. And now you can start thinking about namespaces, how each of these folders is sort of its own thing, and they don't really need to talk to each other too much. And we could put all of our car controller scripts into a, controller namespace, and all of these scripts into an interaction namespace, and our managers into a manager's namespace, and we can kind of really see what's using what and future optimizations. And let's add a new Unity script and let's call it race manager. And look, Ryder even wants to copy my folder structure to be namespaces by default. Okay. In our race manager, this is going to be in charge of starting the race. It's going to be in charge of a timer, and it will have public functions for adding time to the timer and for winning, hitting the finish line. Yeah, it's gonna do all that logic mostly on the timer and keeping track of the win and lose conditions, which makes sense. So let's start with the game state, and we're gonna use the same pattern that we did in Breakout, where we're going to make an enum that will be in charge of all the different states that the game can be in. So in the managers folder, I'm going to make a new class, and I'm going to call it race state, and we'll make it an enum. So race state is going to be countdown 5, 4, 3, 2, 1, go. It's going to be racing. It's going to be at finish line. If an AI beats you, that's not a win state yet. That's just at the finish line. And then it's going to be time up. Sure. Those are the different states the race can possibly be in. And our race manager will keep track of that in a state variable. State. Great. So in awake, the state will be equal to the race state.countdown, but when we start the race, the state will be equal to racing. And we will start the race in start. So that's not a very long countdown. You know, a single frame hasn't even been drawn to the screen yet. But I'm placeholdering, I'm sort of structuring out, like, I want this start race function to be able to happen after other things happen, because I'm going to need the game to work even with a countdown phase, knowing that that's something I want to add in the future. So I can't just do everything in start, because there's going to be the countdown first later. Great. Let's make a timer. So the easiest way to make a timer is with the float, and we're going to count that float down over time. But we're not going to do it this way. No. Because timer is a lot of complexity to it. Adding time to the timer, making sure that we can't add negative time to then have less than negative time, making sure that the having event callbacks in a future upgrade we may or may not ever do, and then getting a pretty sort of whole number seconds left version of the timer. There's a number of different things that go on in a timer, and I want to bottle that logic up into a new class. So under managers, I'm going to add a new class, and I'm going to call it timer. And my timer is going to be the one that has a float for the timer. And this is maybe somewhat of a contrived example to sort of allow us to do custom classes for perhaps the first time that aren't mono behaviors. And it's a good time to do it. A timer is not an uncommon thing. So the way the timer is going to work is start timer. Float seconds. Cool. Tick timer. This will be called by an update function. We don't have an update function in this class, but we'll call it somewhere else. Timer equals timer minus time dot delta time, something I'm sure you probably saw coming. Void. Sorry, that function should be void. So we start the timer, we set it to some value, we tick the time, and we go. This isn't really start, this is more like initiate. And that's just me avoiding teaching us what constructors are, because this is not the time. This is enough for now. We're going to add more features later, like an add time feature. Do that in just a moment. But let's come back to this script and say, instead of setting up the timer to be a float, we'll make it a variable of type timer. And then when the race starts, we will initiate the timer. Is that function not public? It is not. It should be. Public. Great. And we'll initiate, and we'll put 30 seconds on the clock to do make starting race time variable. Okay. And then in update, a serialize. By the time I wrote that comment, I could have done it. In update, we will tick the timer, but only if the race is in. If we're racing, we're not going to tick it if we are in the win state or the lose state. So we're going to take our check, our state, and we're going to say if that state is racing, then tick the timer. And then we want to check if time is up. If timer.time is up. Wouldn't it be great if that function existed? Just something that told us true or false, the time is up. It would be really, this is how I want to write this code. So that's how we should create this other system. So I just did a fancy thing. Let me undo that and show you what I did. So I wrote this function optimistically, even though it doesn't exist. And then I hit Alt-Enter in JetBrains Writer, my sort of autocompletes. And I said, create method timer.time is up. and it made a public reference method. It took a guess that it's a Bool return type, and we can return if our timer is less than or equal to 0. If we're, we're decreasing it, and if we get less than 0, then time is up. In the future, we'll learn about maybe we'll learn about delegates, but at least we'll learn about events. I would actually just have an event of the timer broadcast. Time is up, and when it does, we would just subscribe to that event, and we don't even need to do a check in update. It's just we have a function that's when time is up, and it just gets called by the timer. Oh, that's super nice. But for now, we can deal with having some if statements in the update loop. So if our time is up, we will lose. And that again doesn't exist, so let's do the same thing and make it. And this will just set the state equal to time up. Rename that to out of time. On out of time. Make it out. You have run out of time. Great. Cool. So we can lose when we run out of time, but we can't win yet. So let's do public void go to finish line, or at finish line. And that'll be a public function, and it will set the state equal to being at the finish line. Incredible. But now we know what we can do is we can call this function in our finish line script. So we can go to the finish line script and make a reference to the race manager. Call that race manager. And then when we first interact with the finish line, we will say race manager dot at finish line. And this is the entirety of our race finish line code. It's 10 lines, which is not much. Great. So we can do the finish line we can overlap the finish line, call that function, get to the finish line. But what we can't do yet is control the add nor time when we hit a checkpoint. So let's make a public void add time to timer. And this will need to call some function on our timer, like add time, and it will need to add it. So in our timer, we can write a public function, add time, and this takes a float, seconds to add. When you're dealing with time, it's nice to put the unit somewhere, in a comment and something nearby, because when we're dealing with seconds or milliseconds or microseconds or frames or, it's very common bugs, easy to mess up. Timer equals plus equals seconds to add. So increase the timer by that amount. And seconds to add will be equal to the larger value between the seconds to add will be equal to the larger value between itself and 0, which is my way of saying don't be negative. Now, when you think don't be negative, you might think absolute value, but then the timer would go down and then get big again. It actually would just bounce around 0 because it would be decreasing. Is that right? I don't know, whatever. It would behave wrongly. So here I want to make it the larger value between 0 or the time. So if it's negative, 0. We cannot add negative time to the timer. We could do a little if statement and then give an error. That might be better, but for now, I think that's fine. And then now we can call the timer.addTime function and pass that right along. So having a manager that is sort of the center point of a few other systems doesn't not make sense. So our race manager and our timer, and then our finish line. It talks to the race manager and is dependent on the race manager. It doesn't talk to the timer. It sort of goes through the race manager. So we can think of our race manager as like an interface, the little Venn diagram here, as an interface in between the, we can't get through. We got to go through the race manager, which is not a terrible way to work. is not a terrible way to work. We'll explore something in the future called data-oriented design, where I sort of take these these floats and variables and actually remove them from a model behavior, and I make them accessible sort of separately. And then the race manager would look at some timer scriptable object, and then the UI would look at it, and the checkpoints would look at it, and they would just kind of update. That would be a pretty good way to do this, but we haven't learned about it yet. There are many correct answers. There's no one right way to do anything, which is frustrating because you're trying to do an assignment where you want to just have the right answer, but that is not how this works. We are cooking. We are not doing something else. I don't know. I tried to invent a metaphor on the fly. Let's add a race manager to the game in Unity. That was a lot of code without testing. Let's add a race manager to the game. And then our finish line is going to need that race manager reference. Great. And our checkpoint doesn't. So let's throw some debug.log statements in our race manager to check. Out of time will be debug.log out of time. At finish line will be debug.log at finish line. And then debug.log adding time to timer. And let's go ahead and not have that be 30 seconds and finish up this to do. Starting race time will be the name of this variable. And that's, of course, a float. So starting race time. Clean that up a little bit. And this wants me to rename it to underscore timer, and I say sure. Okay. Alt enter, autocomplete, just slap enter again. Unity is updating. You can do it, I believe. Do I believe? There we go. And then now our race manager, our starting race time is 0. Let's change that to 3 seconds, which will be much easier to test than 30. And we never created a timer. Whoops. No worries. So this timer is currently null. When I made a variable, I set it equal to null. I set it equal to nothing. So let's make a new timer. When we make a new timer, we could make a constructor and initialize this with the starting race time when it's created, just like you can make a vector 3 and give it those x, y, and z values. But I'm not going to rewrite the code. We're just going to set that equal to new. We could even do that up here. But I'm going to do it in awake. Even though it truly does not have a difference in this case. So we're looking for some debug.log statements. I've hit a checkpoint. It doesn't add time to the timer. Oh, and I'm out of time. 2 seconds or 3 seconds have passed. And at finish line. So I was out of time and then I was at the finish line. Which is interesting. So we know that we need to check if we are still in the racing state. And we also need to do that check in the adding checkpoints. You shouldn't run out of time, lose control of your car, have your car sort of slide through the checkpoint and then gain control of your car again. Although it actually kind of sounds kind of interesting. If you could just at least get on the trajectory for it, maybe that's a fun feature, not a bug. But in the meantime, let's just go ahead and do that. If the state is equal to racing, then we can debug.log made it. And then if state is equal to racing, then we'll add time. Otherwise, we'll just do nothing. And out of time, again, if state is equal to racing. And this should be fine because we're sort of checking that in update when we call the function, but we could call this function from somewhere else. I'm just going to leave it as is, do the check twice. I don't care. Okay. So now we need to fix up the checkpoint script so that it can add some time. So how much time gets added to a checkpoint? Don't know. Let's make a variable and put it over there. Time to add. And let's make a race manager reference. And we'll say race manager dot add time to timer, and we'll add whatever the value is in time to add. And we'll get rid of that. We don't need that. We trust. Now we need to reference the race manager in both the checkpoint and the finish line. And it turns out we'll need to reference it like all over the place. And that's kind of annoying because that's a lot of dependencies on this race manager, which I don't love. Cool, made it. Difficult to test, and we haven't done UI yet. So let's go to the race manager. Let's go to the inspector and hit this little thing and switch to debug mode. And this is going to show us all of our variables. We're going to see the race state here. And we see that we're in countdown. That should switch to racing. We can't see in the timer, but and then if we cross the finish line before 13 seconds have passed, at finish line. Great. Nice. Let's go back. All right, so that is roughly the race manager. There's only one thing we do need to do. Well, it is the pickups. Pickups are done. There's only one thing left to do, which is the car input. Let's have the car not move when the player when the game is not racing. So when you're in the countdown or when you're at the finish line, you'll lose input to the car. So we'll do this in car input. We'll make a reference. Again, this is getting to be a little smelly, little code smell here. And we'll just check if the race manager dot state. Ooh, we can't get that. That's not public. So let's go to the race manager and add a public function so that we can read what the state is. We should leave it private because I don't want my input system to be able to change the race state. I want to go through these functions that are doing all their checks in order to update the state. That's going to be important. All I want is to be able to read the race state with a public function called getRaceState, which is a pretty common pattern of what's called a getter, as in getter, get a race state, return state. So this function can be read by anything. We can read the value of it, but we cannot edit the value of state. There is no set race state function. So here on our car input script, race manager dot get race state equal to racing. And if we're checking this a lot, maybe I write this in a function called like, is race happening, is race active, is in gameplay. And then it's even easier to like read. And then now we don't even need to know that race state is like an enum that exists. We can just ask the race, let's do it. Ask the race manager dot is race active. We can probably come up with a better name, and we'll return if state is in the racing state. True when the gameplay state is racing, and not when lose, etc. Great. So if I'm in car input and I want to remember what that does, I can hover my mouse over it. I can save and hover my mouse input over it, and I can see true when the gameplay state is racing and not when this countdown, etc. Oh, summary tag has just appeared in, I'm pointing on my monitor. My summary tag has just appeared in JetBrains Writer over here. Nice. Love that. Love that code documentation. You ever seen the scripting API in Unity? All of that is generated automatically out of tags and comments that are in the code itself. Very clever. Cool. That's what we're going to do in this video. In the next video, we're going to do all the UI, and then we'll be done. We're not going to really take this project further. We're going to keep it simple. So in the first video, we just did a car controller, and I kind of don't care about that. In this video, I got to set that race manager to something. If only there was a way to automatically do that. Well, there is. Car input. Find object singular of type race manager. But what if there are two race managers in the scene? Which one would I find? I don't know. So because of that, we want some way to ensure that there is only one in the scene and give ourselves an easy way to access it that's not as extremely slow like the find function is. Preview of future things that we've actually talked about earlier. It's a singleton pattern, but just Okay, so anyway, the car can reference that. And now it should all work. We just need a timer at the top of the screen. Make that happen next. Let's test it. Let's test it. Let me test. Nice. And I can no longer input, and my car just keeps spinning because it just keeps the previous input it had. Maybe that's not how that should work. Maybe we should check input in the car controller and not in the input script. But again, I kind of like the idea that, like, you know, when the time's up, the player, like the player in the car dies, but the car keeps moving. That's very funny to me. I don't know why it dies. Doesn't need to be morbid. So when the game ends, when you run out of time, we can no longer input and no longer move. Great, it all works. All right. I will see you in part 3, where we're going to use some object-oriented polymorphism again to do some UI stuff, which is going to be very fun, and is also, you know, it's reinforcing the same concepts, right? Where can we use these kinds of programming tools in order to make our lives easier for ourselves while making a game? Cool. See you then.